All right. Let's give a shout out to San Dimas High School football for winning CIF. Please like this video if you enjoyed. You could like the video by clicking the button down here. It's a thumbs up. Okay. Totally boring. Thumbs up for it being boring and awkward right now. Okay. Oh, and you should subscribe. Subscribe.
You're not even recording.
I am. Okay. And, you know, I bet maybe 5 of you really look at this, so.
You spelled subscribe wrong. Just kidding.
I won't say your name for anonymity. Okay, anyways. Here we go. So here's the lesson 42, solving radical equations. Students will solve radical equations. Whenever you see equations, you know automatically that there's going to be an equal sign because equations sounds like equals. So radical, remember radical looks like a square root, or it is a square root basically. So there's going to be something in a radical, and it's going to be equal to something else. Okay, and you're going to solve for that. If it looks scary, it's really not that scary. All right. So the big picture today is getting the radical by itself and squaring. So what's the opposite of a radical sign or a square root? What's the opposite of square root? Like, what's the inverse operation? What's the opposite of square roots? Squaring, right? When you square a radical, it disappears, right? Okay. Here we go, numbers 1 and 2. The first thing, just watch right now. Pencils down, pencils down. First thing I would do is, whenever I say radical sign, is I want to isolate the radical sign. So I want to get rid of this radical sign, especially since there's a letter inside of it. I want this letter to get out of it. So the opposite of a square root is squaring. It's by itself on one side of the equation, so now I can square it. So I'm going to square both sides, put parentheses. Oh. Okay. So on the left-hand side, you are square root and your square cancel out, so we got b plus 3. On the right-hand side, we got 3 squared, which is 9. Okay? So we have the canceled out square root sign, and we have 3 squared, which is 9. Now we just solve it like we would have Algebra 1 problem, or pre-algebra problem for that matter. Subtract 3 on both sides, you got b is equal to 6. Okay, what this is saying is if I plug 6 in here, 6 plus 3 is 9, square root of 9 is 3, right? All right. We also check for extraneous solutions, which means solutions that don't work. They should work, but they don't because it either makes it undefined or it's like a negative square root. So if you put this in here, we figure out b is equal to 6. So 6 plus 3 is 9. Square root of 9 is 3. So this works out. There's no undefined answers here. Okay, watch me do number 2. Number 2, there's 2 square roots. They're both separated, but if they weren't, you'd want one by itself. Once you have one by itself, you square both sides. So we have one square root equal to another square root. So you take both sides and you square it. Okay, so when you square one side, square root cancels out with a square. So we got 2x minus 27 is equal to, this square root cancels out with this 2. So we got x over 5. And we have a binomial, which is equal to a fraction. We want to get rid of this fraction. So I'm going to multiply everything by the LCD. This left side, the LCD here is 1. I can put a 1 under here. So I'm going to multiply this by 5. So I'm going to multiply the right side by 5 and the left side by 5. Because I want to get rid of that denominator. So 5 and 5 cancel out. That's why I did that, leaving just x. Okay, on the left-hand side, distribute the 5. 5 times 2x is 10x. 5 times negative 27 is negative 135. Okay. I'm going to subtract x on this side and also on the left-hand side. And add 135. So we get 9x is equal to 135. Divide both sides by 9, and you get x is equal to 15. Check for extraneous solutions. Checking for extraneous solutions, 15, plugging it in, 2 times 15 is 30, 30 minus 27 is rad 3. Okay. Also, x, 15 divided by 5 is 3, so rad 3 is equal to rad 3, it works out. Rad 3 is a irrational number, so we don't have to worry about putting it in or solving for it. We just want to make sure we don't have an undefined denominator, okay? And that's basically it, okay? So, any questions? It's pretty straightforward, right? It's pretty easy. So what I'd like you to do is turn to your neighbor, explain. Ones tell the ones, or ones tell the twos about number 1, twos tell the ones about number 2. Ready, set, go. Okay, so number 3. Okay, number 3, what I'd like you to do, work it out. Turn to your neighbor, make sure you're explaining the steps to them while you're doing number 3. And make sure you're getting a very similar answer, or the same answer.
Wait, I got this. Don't tell me. Well, tell me if I'm wrong.
So, on this example, we have a square root. It's by itself, so you can square it. Shh.
Got you.
So we got 2 squared, which is going to be 4. 4 is going to be equal to n minus 1. Add 1 to both sides. You get 5 is equal to n. And then use the symmetric property, n is equal to 5. There you go. Number 4, by yourselves. Ready, set, go. Okay, good. So if you work this one out, you get a is equal to 7. A is equal to 7. Okay, I'm not going to go through this one. Everyone got that one? Number 5. Number 5, here we go. On your whiteboards. Ready, set, go. Okay, so in this example, you should have squared both sides, of course, because there's a square root on each side. We want to get rid of it. Cancels out. So we get x over 4 is equal to 2x minus 14. Multiply both sides by 4. So we got x is equal to 8x minus 56. Okay, and subtract 8x on both sides. So we got negative 7x is equal to negative 56. Divide both sides by negative 7. So we get x is equal to positive 8. Okay? And this concludes our lesson.